In this video, we are going to be working some application problems. I'm going to read the first statement here on the problem, and then I'm going to draw out what that would look like. It says a wire is stretched from the ground to the top of an antenna tower. So let's see, if we have an antenna tower, and here's the ground, and then here's a wire that's stretched from the ground to the top of the antenna tower, or top of the tower. Now, let's read the next statements and see if we can put what each one of these sides are going to be represented by. It says the wire is 17 feet long. So I know that this side is going to be 17. The height of the tower, so we are talking about this distance right here. The height of the tower is 7 feet greater than the distance from the tower's base to the end of the wire. So the tower's base is here, the end of the wire there. So the tower side is 7 feet greater than that ground side. So we're going to call the ground X. If the tower is 7 feet more than that, it's going to be X plus 7. Now, you'll notice that when you draw out this problem, you are creating what is called a right triangle. Whenever you are talking about the sides of a right triangle, you may have heard of the Pythagorean theorem before. A squared plus b squared is equal to c squared. The ground and the tower are the A and B side. The wire, which is the longest side, it's called the hypotenuse, has to be the C side. So let's fill in here. So let's call this ground side our A side. So it's going to be X, and then square it from the formula, plus my B side, which is X plus 7 squared, equals the C side, which is the 17 squared. Now, let's see if we can simplify this equation. So on the left, I'm going to have X squared. But then you notice I have X plus 7. I need to square that whole side. So I'm going to do this here, because I'm going to have to FOIL. So my first X times X gives me X squared. My outer X times positive 7 is 7X. My inner is another plus 7X. And then my last 7 times 7 gives me positive 49. The terms in the middle are like terms, so when I put those together, I'm actually going to have 14X. So X squared plus 14X plus 49 is what this X plus 7 squared ended up being. So I have plus X squared plus 14X plus 49 equals 17 squared, which gives me 289. So once I have this on the left side, I notice that I have like terms. I can put my X squareds together. I actually have 2 of them, right? 1X squared plus 1 more X squared gives me 2. X squared plus 14X plus 49 equals 289. So now I am solving an equation that has the highest exponent of a 2, which means it's actually a quadratic equation. I have my quad calculator that I can use, but before I can plug in my A and B and C, remember in the last video, You had all the terms, the x squared, the x, and the constant on one side, and what was it always equal to? It was always equal to 0. So I need to make that happen. I'm going to subtract the 289 from both sides. So now I have 2x squared plus 14x minus 49 minus 289 gives me negative 240 equals 0. So now I can go to my quad calculator and type in my a is in front of x squared, so it's a 2. My b is in front of x, so it's 14, and my c is negative 240. So I'm going to put these numbers in my quad calculator. A was 2, B was 14, and C was negative 240. And then I'm going to calculate, and let's see what we get. We get 8 and negative 15. Now, let's think about what are these numbers representing? What is x representing and x plus 7 representing? X is representing the distance from the base of the tower to the end of the wire, that ground side. So x, it's not going to be a negative number, right? Because you're not going to be negative amount of feet away. So you are going to be that positive 8 is the ground side. Well, if that's 8 and the tower is 7 feet more than that, then the tower is 8 plus 7, which is 15. So the distance from the wire to the tower was 8. And the height of the tower, which was 7 feet greater, would be 15. Okay, let's look at this next problem. The foot of an extension ladder is 5 feet from a wall. So let's draw this out again. So here's my ladder, and it's leaning up against the wall. The foot of an extension ladder, so that's talking about right here, is 5 feet from a wall. So it's talking about, and it's important where you put your numbers. The foot of the ladder is 5 feet from the wall, so that's gonna be the 5. Now it says the height that the ladder reaches on the wall and the length of the ladder are consecutive integers. What does that mean? It means that the height that the ladder reaches and then the length of the ladder are consecutive integers, which means one comes right after the other. So I am going to call the wall side x, and if the ladder is the very next number, that side's going to be x plus 1. So again, it made a right triangle like the last one, so I am going to use my Pythagorean theorem. Now remember, this side here, the ladder side, has to be the C. That diagonal, called the hypotenuse, has to be the C side. So I'm going to write this out. So the ground will be 5 squared plus the wall side will be x squared equals the ladder side, which will be x plus 1 squared. So let's look at what we have here. 5 squared gives me 25 plus x squared equals, once again, I have x plus 1 squared, which means x plus 1 times itself. So I will FOIL. My first x times x gives me x squared. My outer x times 1 gives me x. My inner 1 times x gives me another x. And then my last 1 times 1 gives me 1. Once again, these middle terms are like terms, so I'm going to put those together. So it ends up that I have x squared. 1x and another 1x gives me 2x plus 1. So that's what the right side of the equation ends up being. Once you do the x plus 1 squared, you get x squared plus 2x plus 1. So it's looking quadratic again, since the highest exponent in this equation is squared. But look what happens. Remember, if you're going to use your quad calculator, all the terms have to be on one side set equal to 0. Look what happens when you put your x squareds on the same side as each other. I'd have to subtract it on the left, which means I'd have to do the same thing on the right. Well, what happened in that process is it actually canceled it off of both sides. So all I have left on the left side of the equation is the 25 equals, on the right, I've got 2x plus 1. So I don't have a quadratic equation anymore. It's just a plain x equation. I need to get x by itself. So I'm going to subtract 1 from both sides. So now I've got the 2x equals 24. And then divide by 2. So now I have x equals 12. So let's see how that relates to our problem. Which side of this drawing is the x? It's the wall side. So that is 12, which means the ladder side is going to be 12 plus 1, which gives me 13. Be careful when you are working this problem, because the only thing that it wants to know is the length of the ladder. It doesn't want to know what x is. It wants to know what the length of the ladder is, which is that side, which would be 13.